Hi, welcome to my video on Solve Trig Equations, Quadratics Part 7. And in this one I'm doing some extra equations just for extra practice to show you some of the algebra skills needed. And the first one, solve for theta. 0 is less than or equal to theta, less than 360. And notice it's in degrees. And when I look at the equation, I have cos theta minus 2 divided by 3 equals secant theta. So we have to change secant theta to secant is the reciprocal of s. I need a c, so it's the reciprocal of cos theta. And as a result of having a denominator of cos theta cannot be equal to 0. That means theta cannot be equal to, so cos is the x, so x is 0 at 90 and 270. And so let's just review the unit circle just for a second. Again, very valuable to make 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And so we cannot have a 90 or 270 because if we do, secant will be undefined, division by 0. Now we have two fractions equal, so let's cross multiply. So cos theta times cos theta minus 2 equals 3 times 1. Cross multiply. So cos theta times cos theta is cos squared theta minus 2 cos theta equals 3. And we have a quadratic, or cos squared, so we'll move all expressions to the left side. And the minus 3, when you move it plus 3 over, it becomes a minus 3, so it's in descending order. Quadratic. And we have a 1 here, so this should be easy to factor. There's no GCF, so we do double brackets. Cos squared is cos theta times cos theta. And 3 is a 3 times 1, so that's the first terms, cos squared. The last term is a 3, but notice the product is negative, and the sum is negative 2, so the product is negative 3. That means one of these numbers is positive and one is negative, but the sum is negative, so the larger I have a negative 3 plus 1. Multiply negative 3 times 1, negative 3, add, you get a negative 2. Because if you do FOIL on this, you'll come back to this trinomial. That means we have two factors that are equal to 0, because we have quadratics have two sets of factors. And we continue to solve for cos theta equals 3, cos theta equals negative 1. And cos theta cannot equal 3. Again, if we use the calculator, that theta is equal to cos to the negative 1 on 3. The calculator reads out an error. So theta here, there's no solution or no answer. And also, if you think about it, just to review, cos, the cos of 0 is 1. The cos of 90 is 0. The cos of 180 is negative 1. The cos of 270 is 0. And the cos of 360 is 1. So this is a 90. That's 180, and that's 270. Then the cos graph is a sideways C. There it is there. Notice this is a 1, this is a negative 1. So the domain for cos is negative 1 is less than or equal to cos theta less than or equal to 1. So that's why we can't have a 3 for a cos graph, for cos, because the maximum is 1, the minimum is negative 1, and all numbers in between. Cos is a negative 1, cos is the x is the negative 1 at the 180. So cos equals 180 degrees. and the answers are from 0 to 360, not including 360. So the final answer, so the answer to this problem is 180 degrees. Okay, let's continue. And we have another one to do. Solve for theta, and 0 is less than or equal to theta less than 2 pi. And if you think about it, we have to express the answers in terms of radian, but 2 pi is related to 360. So what I do, I convert my radians to degrees, so I know I'm going to pick up my answers between 0 and 360, and when I get them done, then I'll convert them to radians, and I'll fully answer the question. So we have a bracket and we have a negative. So we have PEMDAS is PEMDAS. So we have brackets are already done because you can't simplify them. We have to do the exponents. So 2 sine squared theta minus root 3. So I'm writing all this down just to get over to that exponent. And a negative exponent flips the fraction, so that's 3 to the 1, or just 3. Now we have the exponent done. Now we have to do the multiplication. So 2 sine squared theta. Negative root 3 times sine is a negative root 3 sine theta. Negative root 3 times a negative root 3 is a positive. Root 3 times root 3 is 3. Or root 3 times root 3 is root 9, which is 3. So now we have a 3 on each side. So I could move this 3 over and make it negative, but we can scratch those out because they're on opposite sides. So that means that 2 sine squared theta minus root 3 sine theta is equal to 0. And now we look for our first rule in factoring is GCF, so we'll take the sine theta out. Sine is common in both terms. So 2 sine squared divided by sine is 2 sine. And a negative root 3 sine divided by sine is negative root 3. Again, we got a quadratic, so we got 2 answers. So sine theta, or 2 possible sets of answers. Sine theta is equal to 0, or 2 sine theta minus root 3 is equal to 0. This one is already solved, so let's solve this one. 2 sine theta equals root 3 positive, divide by 2. So sine theta equals root 3 divided by 2. And we have sine is equal to 0. So again, this very important unit circle. I keep writing it down, lots of practice. And there it is. Sine is the y. Where's y? 0. Y is 0 right here. That's at 0 degrees. And sine is 0 right here at 180 degrees. I can go to 360, but I can't use 3 because it's not equal to 360. I can only put up the answers between 0 equal to 0 and 360. Now, how about sine is root 3 over 2? Well, we add sugar to coffee. This is the CAST rule, C-A-S-T, but I like to use A-S-T-C, add sugar to coffee, because that's all is positive. Sine is positive, tan is positive, and cos is positive. And what you don't see positive here, then it must be negative. So sine is positive in 1 and 2. So we'll go quadrant 1, and we'll go to quadrant 2. Draw a circle, and I like to do them separate. So sine is positive in quadrant 1, perpendicular to the x-axis. Sine is positive in quadrant 2, perpendicular. Remember, sine is the y. So y is positive in quadrants 1 and 2. And we have sine is the y, so we have y is root 3 over 2 in each triangle. Notice the y is going up, and y is positive going up. So this is a 1 and a 1, and this is a half plus and this is a half minus, but because that's root 3 over 2, opposite root 3 over 2 is a 60. So this angle here is a 60, so the reference angle is 60. This angle here is 30. And this angle is 30 because it's 30, 60, 90 right triangle. Because the radius of the circle, this point here is 1, comma 0. So what happens? The radius of the circle is 1, so this is the unit circle. So the reference angle is 60. So in the first quadrant, theta is the reference angle, so it's 60 degrees. In the second quadrant, theta is equal to 180 minus the reference angle, which is 60. So that's 120. So now we got to pick out the angles between 0 and 360. So we have a 0, so theta is 0 degrees. And we have a 60 degrees. We have 120 degrees. And we have 180. We put them in order. Now we got to convert these to radians. So that's in degrees. So now we got to convert to radians. Because 0 is less than or equal to pi, less than or equal to theta, less than 2 pi. We need our answers not in degrees, but in radians. So 0 degrees is 0 radians. And 60 degrees. Well, let's convert 60. 60 times pi over 180. Reduce 60 and 1. 60 is a 3. So 60 is a pi over 3. 120 times pi over 180. Put a degree, I put degrees there. But you know what I mean. It's 120 degrees, 180 degrees. You cancel the zeros because you're dividing by 10. 6 into 18 goes 3. 6 into 12 goes 2. So 120 is 2 pi over 3. And notice 60 and 120 goes 2. Pi over 3 is 180 divided by 3 is 60. So that means that these two answers will have pi over 3 because the reference angle is 60. So that's pi over 3 is a 60 times 2 is 120. And 180 degrees, well, we all should know what that is. 180 degrees is 180 degrees multiplied by 180 over pi. 180 cancels, so we get pi. So there's the 4 answers in terms of a radian. And the last one to do as an extra practice, but I wanted to do this one because we have fractions. And also we have fractions, we have denominators that we cannot have equal to 0. So if we do cos theta plus 1 cannot equal 0. That means cos theta cannot equal negative 1. That means theta is, if we look at the circle again, just to make sure, keep the paper steady here. And here it is. So cos is related to the x. So x is negative 1. X is 1, 0, negative 1, 0. X is negative 1 here. So that means theta cannot equal 180 degrees. And also we have cos theta here. That's the denominator, so it cannot be equal to 0. So cos is 0. Cos is the x. That's at 90 and 270. So that means theta cannot equal 90 degrees or 270 degrees. So if we get either one of these angles, you can't use them because it makes the denominator 0. So let's continue. We have an LCD because we have fractions. So the best way to solve equation with fractions, I find, is to multiply through by the LCD. So the LCD is cos theta, which is this denominator, times cos theta plus 1, because they're different denominators. So let's go down here. Let's take cos theta and cos theta plus 1 and multiply by 1 over cos theta plus 1. And cos theta plus 1 is your LCD. I'm going to multiply it by 1 over cos theta. And we have cos theta and cos theta plus 1 times 2. So notice I wrote it down so you can see what's happening. The LCD is multiplied by each of these parts of the equation. What happens when you multiply by the LCD, every denominator should cancel. So cos theta plus 1 cancels out. So I get cos times 1, which is cos theta. And when we multiply here, the cos thetas cancel. So I get 1 times cos theta plus 1. So that's cos theta plus 1 equals sign. Notice I have a 2 and a cos and cos theta plus 1. So let's do that multiplication. Let's do that multiplication right here. So that's 2 cos theta plus 1. So what I did, I took the two monomials, I took the 2 and multiplied by cos theta, and I wrote it right there, and I left cos theta plus 1 alone. Now when I multiply here, I have 2 cos squared theta. 2 cos times cos is 2 cos squared, and 2 cos, remember I'm leaving out the theta, so 2 cos times 1 is 2 cos theta. So multiply the 2 by the cos theta first, and then you multiply by the binomial after. It's easier. Now you can multiply cos theta by these two, and then multiply by 2 after. So, but I prefer to multiply the 2 monomials and then multiply by the binomial. So we have those done. Simplify each side. So we get 2 cos theta plus 1 equals 2 cos theta squared. So cos plus cos is 2 cos plus 1, and we didn't change this. And we have, if you notice, 2 cos is on each side, so they cancel out. So that means I have 1 equals 2 cos squared theta. So rather than move it around, I'm just going to flip the equation around. So 1 equals 2 cos squared theta, flip it around. 2 cos squared theta equals 1. Divide by 2. So that means cos squared is equal to 1/2. And we want to solve this, so we'll do the square root of each side. So the square root of cos theta equals plus minus the square root of 1/2. So the square root of cos squared is cos theta, and this is plus minus. Now let's simplify the square root of 1/2. The square root of 1/2 is the square root of 1 over the square root of 2. We're not allowed to, shouldn't have a radical in the denominator, so we want to rationalize it, so we multiply by root 2 over root 2. So 1, the root of 1 is 1, so that's 1 times root 2 is root 2. Root 2 times root 2 is 2. Root 2 times root 2 is root 4, which is 2. So that becomes root 2 over 2. So what we have is cos theta is equal to root 2 over 2, or cos theta is equal to negative root 2 over 2. So, as a result, cos is positive and cos is negative. Now, so what happens? We add sugar to coffee. So if we deal with the positive one, that means we're dealing with quadrants 1 and 4. So just draw this quadrant 1. Put in quadrant 4. In quadrant 1, terminal arm perpendicular to the x-axis. Quadrant 4, terminal arm perpendicular to the x-axis. There's the right angle. And root 2 over 2 is x. So x is root 2 over 2 for both of these. X is root 2 over 2. And because it's root 2 over 2, then automatically that means that this side here is root 2 over 2, 1. That's the hypotenuse. That's root 2 over 2. This side here is negative root 2 over 2. And because it's a root 2 over 2, then that's a 45-degree reference angle. That's a 45-degree reference angle. This angle here is 45. This angle is 45. So in this quadrant, theta in the first quadrant is the reference angle, so we have a 45 degrees. And in this quadrant, which is the fourth quadrant, we have 360 minus the reference angle of 45. So that's 315 degrees. And now we have cos is positive in 1 of 4. So cos is negative in 2 and 3. But we're going to get the same reference angle because we have a root 2 over 2. We just have different quadrants. So in quadrant 2, cos is negative. In quadrant 3, cos is negative. But because we got root 2 over 2, we know the reference angle is 45 for both of these also. Cos is negative. I'll just put that in right there. Cos is negative right here. Cos is dx. So that means sine is root 2 over 2, hypotenuse 1. And sine is negative root 2 over 2, hypotenuse of 1. But the reference angle for both of these is 45. 45 here too. But in the second quadrant, theta is 180 minus the reference, which is 135. And in the third quadrant, theta is 180 plus the reference, which is 225. Okay, so now we want all possibles. So these are only, but remember, the sine graph or the cos graph is periodic. So the cos graph, allow me to explain right here, the cos graph is periodic. So the cos graph goes like that, between 0 and 360. And then it goes again between 0 and 360. So that's a 720 over here. And it keeps going backwards like this. So it's periodic. And the period of cos, or sine, is 360 degrees. So that means I'm going to take each of these angles and add on. Here we go. So the answer is 45, add on 360 degrees, which is the period, with an n belongs to the integers. And we take them in order. We can go 135 plus 360 degrees, and where n belongs to the integers. And the next one is 225, so we got 225 degrees, add on 360 degrees times n, where n belongs to the integers. And we have 315, add on 360 times n, where n belongs. So now I use n. Like n is a number, like n is an integer. Like we say n belongs to the integers, so n is representing 0, 1, 2, 3, 4, -1, -2, -3, -4. Some teachers or books use k. Put a k here, k here. So it was k or it was n. It only means the k is an integer. So that's all the answers, all the possible answers. Because remember, the period of cos and sine is 360. So these repeat itself every 360 degrees. And if you just look at this one, when n is 0, that's 0, so you get a 45. When n is 1, you get 360 plus 45, you get 405. When n is -1, you subtract the 360, and you get a negative 315. So you get all the answers. So that's extra practice, excuse me, in solving equations. And if you like what I'm doing, click the like button, subscribe to my channel, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.